we have discussed about the content cost function, and now we are discussing about style cost function. What is the meaning of style of an image? We are taking the input image. This is an RGB image. We have used convolutional neural network. Finally, fully connected layer, and we are classifying something. This is a layer L. So by using this layer L's activation, we want to measure the style. What is actually style? Style is nothing but it is the correlation between activations of the different channels of this layer L. We will take one example. This layer L, we are representing it as the height of this layer is NH and width is NW and number of channels NC. Now we are interested to see how many channels are there. In reality, there are many channels, but for the explanation purpose, we are considering NC equal to 5. These 5 channels are represented with the different 5 colors. Red color represents one channel, yellow color represents one channel, like that 5 colors we use to represent the 5 channels. Now the activations of the red channel, now the activations of this yellow channel, now the activations of channel 1 and the activations of channel 2. The similarity between the activations of these 2 channels are the correlation between the activations of these 2 channels. The correlation, we can say it is not actually similarity. The correlation between the 2 channels is called as style. So if we are taking the style of this layer, means we are trying to find how channel 1 is correlated with respect to channel 2. Channel 2 is channel 1 is how it is correlated to channel 3, like that channel 1 how it is correlated to channel 5. Channel 1's activation units, how they are being correlated with the different channels. That is how we are measuring the style. Example, this is the style image and this is the generated image. We have discussed already 3 images: content image, style image we are using in order to create a generated image. The first layer is representing, example, the first layer information equivalent is represented by using this, and example second layer information is represented by using this. Means the neuron, the hidden neuron which is activating for the vertical strike marks, this particular hidden neuron, it is being activated for the vertical strike marks. It is detecting that vertical strike marks, and this neuron is detecting the orange color. So the correlation between these 2 channels is indicating that whenever we are getting some vertical marks, the background of those vertical marks, if that is orange, then these 2 are correlated. That is how we are measuring the style of an image. If uncorrelated means the strikes don't have the background orange color, then we can call that is uncorrelation. So we measure the correlation across the different channels of this layer for the style image, and we measure the correlation across the different channels of this generated image. We call that as a style, and we measure the difference between the style of a style image and the style of the generated image. This is the style matrix, where A is representing the activation. So we have the activation function. I means width, J means height. We have represented here I means height and J means width, and K means a number of channels. L is the particular layer we are representing. Then the style is given as GL, where GL is nothing but NCL by NCL, which is representing, if we have 5 layers, example, if we have 5 layers, then in order to 5 channels in a layer, if we have 5 channels in a layer L, then in order to represent the style matrix in the layer L, we are finding what is the correlation between channel 1 and 2, channel 1 and 3, channel 1 and 4, channel 1 and 5. Similarly, channel 2 and 3, channel 2 and 4, channel 2 and 5, we will get a 5 by 5 matrix. So this is style matrix we are representing with Z is a NC by NC matrix. It is nothing but we are multiplying the activation unit of one channel with the another channel activation unit. So this is the style matrix for the style image. This is the style matrix for the generated image. This representation in linear algebra, it is called as gram matrix. That's why we are representing as capital G. So this is style matrix for the style image. This is style matrix for the generated image. Now we find the difference between these two. So total J style, cost of the style, cost function of the style cost function is given by Fibonacci norm. The difference between the style matrix for the style image, style matrix for the generated image, and we are finding the individual difference, and it is like we are finding the element wise different, and after that squaring them and adding. This is what we are performing here in order to get the cost function of that particular layer L. This is called style cost function. We have taken a constant here. This is anyway we are using the constant beta before the style cost function. So this is called as another, you can think this is another constant we are using, but this is only for the one layer. If we want to represent for the all layers in order to get a very good accurate way, then for all layers capital J style is nothing but summation of the style cost functions for each layer. That will give the total style cost function. So J of Z is the total cost function, is nothing but it is the summation of content cost function we discussed previously, style cost function we discussed now. The coefficient of the content cost function is alpha. The coefficient of the style cost function is beta. So finally, we discussed the content cost function and the style cost function. These two cost functions combinedly we are getting the neural style transfer total cost function.